In this module, we're going to be looking at something called the locking level, and we shall begin by answering the question, what is the locking level, before moving into some of the specifics concerning point locking, locking of other movable infrastructure, and opposing locking. So what is the locking level? Well, the locking level has its origins in the steam age with mechanical interlockings that prevented signallers moving levers to control signals and points in unsafe combinations. Now, as in the steam age, the locking level is concerned with internal states within an interlocking, be they lever positions of relays in electromechanical interlockings, or logical states within a computer-based interlocking. Its role is to prevent unsafe combinations of states within the interlocking that then lead to unsafe combinations of commands being issued to signals and points. For example, commanding points to move in a direction that is inconsistent with a route set over them for which a signal is to display a proceed aspect, or setting routes in opposite directions over the same piece of track that then signals could be authorized to display proceed aspects for. A key part of the locking level is point locking, which ensures that points are commanded to the positions required by any signalling route set over them. Hence, trains can only be authorized to travel over the route and all the points in the route if they are commanded into the required positions. And similarly, they are prevented from changing their commanded position whilst that route remains set. However, it is important to stress that we're only talking about the commanded position here, not where the points are physically located. Detecting that the points are physically in the correct position and locked in their position is a function of the aspect level, which we're going to look at in the next module. The locking level also locks other movable infrastructures, such as swing bridges, ensuring that they are commanded to be locked in the position required for a route that is set over them and cannot be unlocked and allowed to move whilst that route remains set. Certain types of level crossing also need to be commanded closed to road traffic when routes are set over them and not permitted to open whilst that route remains set. The locking level also prevents opposing locking, usually. That is to say, routes being set in the opposite direction over the same piece of track. And there's two types of opposing routes, some called directly opposing and some called indirectly opposing. We're going to see the difference in the next couple of slides. A directly opposing route is one that follows the same section of track with all the points commanded in the same position, with the only difference being it is set in the opposite direction. So the red route in the diagram is directly opposing to the golden route that we want to set in the diagram. An indirectly opposing route is one that requires some set of points in a slightly different position, so the point locking should prevent it being set at the same time. However, if a train passes through an indirectly opposing route, it gets to a position past the points, the blue section in the diagram, where it's on a section of track that is directly opposing, and the points, if they're allowed to release behind the train, can then lead to a situation where a train that was in the route that initially wasn't opposing has now come to a point where it is opposing. So we say it's an indirectly opposing route. So I said usually opposing locking is applied because there are situations when it can be overridden in specific scenarios subject to risk assessment. One is when you want to authorize a train to couple up to the front of another train using a calling on route. As we see in the diagram, a route's been set into a section, the last section of the route remains locked, and a calling on route is set in the opposite direction to allow a locomotive to couple onto the front of it. Also in sidings, we can set two routes in an opposite direction and display proceed aspects for both of them to allow a train to shunt backwards and forwards in a head shunt. This is only allowed in specific scenarios for low-speed passenger moves and subject to other controls and site-specific risk assessment. So I've introduced you to the locking level, having its origins in mechanical interlocking and having the role to prevent unsafe combinations of states within the interlocking that could lead to unsafe combinations of commands or signals, points and other movable infrastructure. Locks points, other movable infrastructure and certain types of level crossing. Usually prevents directly opposing routes being set. However, there are exceptions to that where opposing locking can be overridden to allow a train into an occupied section or to shunt backwards and forwards in the siding. In the next module, we're going to be looking at something called the aspect level, which is another key part of interlocking functionality. So please join me then.